Okay, so the only thing that's changing today is what it looks like. Nothing, ready for my joke? Nothing functional changes. Okay, so first we got to do a little bit of work here, all right? Up until now, we've been discussing this. You have an IV, you do some math, and you get a DV, right? And early in the unit, we always had values for IV and DV, yes? Kilometers per hour, minute, meters per second, blah, 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 right? Depth per minute for the diver. We've done all those, yeah? And then we changed it a little bit to X's and Y's so we could put it on a graph, yeah? Mm-hmm. So it became X with some math got me Y, yes? And then we gave a bunch of different names to X and Y. X was the input, Y was the output, X made a set that was the domain, Y made a set that was the range, and we've got all those names for essentially the same thing, yes? Right? Okay. Now I need you all to think back, cast your minds back to the 5th grade. In the 5th grade, if you went to school in Canada, your textbooks showed you this construction. Don't write this down. And you guys got an input of 10, and then you dropped it into the function machine and you added 2, and that got you 12. And then you drop that into the function machine and you divide it by 4, and that got you 3. And 3 became your output. Whatever. The point is you have seen it before. Okay, some of you may not have, but the vast majority of you will have seen a drawing of the function machine. What was the function machine doing? You started with an input, you did some math, and you got an output. Isn't that the same as what we are doing in the 10th grade?
Yes.
More proof that you have been doing the same math since you were 9. Okay? Everybody cool? Okay, now in grade 10, and 11 and 12 in university, we don't have the stupid little function machine. We do this. We write f x, and that stands for, we read it as the f of x. Okay? And that means that is the name of whatever the function is, and that is the input. When you apply the function rules to your input, what do you get? Your output. Is everyone okay with the theory behind what we are going to do today? Don't worry, we're going to go deeper into what all these new symbols mean. But right now, are you okay with the theory? You should be, because most of you have seen this schmozzle. Yes? Okay. So now, looking at this equation right here, this is in the notation that we are used to, isn't it? It's got x's and y's. We've got a table of values with x's and y's. How do you fill this in? What do you have to do with this in order to fill in the blanks? Vanessa.
You have to put in a number, so it's a -2, so then...
Right. How do you know you're going to use -2?
Because that's the first...
Because that is our first input. Because it is in the x column. Everybody cool? So the first thing I'm going to do is y equals 1/2. What's x? -2 minus 2. What is 1/2 times -2? What kind of one? -1. What is -1 take away to? -3. So when x is -2, that's my input. What's my output? -3. Now you all remember from the 9th grade, this x and y now gives me a point on the graph, doesn't it? The point on the graph is -2, -3. Cool? All right. You guys fill in the next 3. Go. I'm not going to do them because I'm going to do them in my head. Now, some of you probably can't do this in your head. That's okay. What are you going to use to find the outputs? You're going to use your calculators, yeah? Everybody cool? Everyone's cool? Everyone understands how the chart got filled in? Yes? You must stop me if you do not understand this. Now, because I think you're liars, I'm going to say a few people's names right now to make sure they get it. B-Rad. Do you understand where these numbers came from? These two are causing you trouble? Okay. What is the value for x here? 0. We've already done -2. Now we're going to do 0. So I have y equals 1/2 times not x anymore. It's 0, yes? Minus 2. 1/2 times 0 is 0. 0 minus 2 is -2. So when x is 0, y is -2. Got it? Okay. This one, 1/2 minus 2 is -1.5. Okay? Everybody good? Mikey? Okay. Whatever numbers are here, you put them wherever there's an x. That's grade 9 work. All of you should understand that. Yes? Okay. Now it says, I've made my chart, right? Everyone can do that? Inputs, outputs? Everyone's aces, yeah? Okay. Now, this y equals 1/2 x minus 2 has a spot for an input and a spot for an output. In grade 10, this transforms to this. F of x equals 1/2 x minus 2. Now look closely. These are the same, are they not? Great. So, if this was input in the old way we wrote it, what do you think this is? Input still. Now, you guys aren't stupid. There's only input and output. right? So if this is input, then this must be output, correct? So what does that make this? The output. So essentially what I have done is we have now replaced y is now f of x, because x is our input and the function is the math we are doing to it. Does everyone understand? Now, this girl is Maddie, yeah? This girl is Vanessa, yeah? I get it, yeah, funny. Maddie and happy. Mad, happy,
Yeah.
Maddie. This girl is snarky.
Okay, Sharky.
All right. Why must I give them different names? Because they're different people. So what if I have a different math rule? I give it a different name. So it might be g of x, because f of x is one set of math that I'm doing. G of x is a different set of math. Does everybody understand? It's just the function's name. Everybody okay? All right, let's move along. So this is now what we are given. You're used to seeing this as y equals 2x minus 7, yes? And you're used to the table of values being x, y. Put in the x, get the y, correct? That's old news. In grade 10, we do this. F of x equals 2x minus 7. And my table of values are now x and what? F of x, because that's my output. Is everyone okay? These are just baby steps. We're all good, yeah? It's just a different name for the same thing. Y's were the outputs last year. This year, this is what we call the outputs. But they're still the outputs. Is everyone good? Okay. Now, I want you to find me the f of 2. Now, what up until this point has lived inside these brackets? X. But now that x is a 2, isn't it? So the f of 2 must be 2 times what? 2 minus 7. So when I input 2, what is my output?
-5. Oh, x.
2 times 2, 4 minus 7, -3. Is everyone good? Great. So now you do the second one. The f of what? -3. X is now -3, so what do I write instead of x in my equation? -3, because the x has become -3. This was an x, so I write -3. Then I subtract 7. What's the answer? You may need your calculator because you guys are bad at subtracting negatives. -13. So what was my input in the blue function? -3. What was my output? -13. Now, do these give me points on a graph?
Yeah, they're linear.
What are they?
It would be 2,
-3 and 3, negative 13. And if I were going to put them on a graph, which we're about to do, I would just find those 2 points. What would I do once I had those 2 points? Pardon? I'm sorry, Nick. You would put a dot at each point, and then what would you do? You would connect them. We'll talk about... Yeah, because they're just numbers. Everyone good? Okay, so each time you will notice I've shown you one small new thing, yes? So the small new thing we're doing now is this. F of x. Whatever is here goes in for x in the function. Everybody read that out loud right now.
Whatever is here goes in for x in the function.
Say it again.
Whatever is here goes in for x in the function.
Say it again.
Whatever is here goes in for x in the function.
One more time.
Whatever is here goes in for x in the function.
You are laughing, but this is the level that you guys have taken me to.
It's true, a help.
So if I have f of negative 1.2, what will I put in this function? 2 negative 1.2 minus 7. Got it? What if I want the f of 3/8? 2 times 3/8 minus 7. Everybody got it? What if it looks really weird? I want the f of 7p. What do you write? 2 times 7p minus 7. Got it? Whatever is there goes there. Even if it's another variable or a different letter or a different symbol. Do you understand me? So if I had the f of lightning bolt, what would you write? 2 lightning bolt minus 7. Do you understand? That's done.
Brackets?
That's done. You could if you wanted to.
Does it matter?
No.
Oh.
That is done. Is everybody okay? One more time. Whatever is here goes in for x. What if it's not an x? It goes in for whatever letter is there. Got it? Okay. Turn your page over. May I go on? All right. Okay. I have a new function with a new name, don't I? Does anything functionally change?
Nay.
No. We've just changed the name of the function. So there is what I am working with. Right? So I need to make my table if I am going to graph it. Yes? This side are my inputs. This side are my outputs. What are the 3 inputs that this question says I must use? 6, negative 3, and 0. Correct? So, the first one I need is the g of 6. Uh-oh. Is something in the brackets? Yes, there is. Where do I put it, boys and girls?
Oh, what's up there? Yogi Bear, what the hell?
Right you are, baby. Where do I put the 6? Everywhere that I see on X. Negative 2/3. And then there was an X. Is there X's anymore? What is there now? 6 plus 1.
Now, a great many of you are bad at fractions.
That's decimal.
That's your problem. Negative 2 times 6 is negative 12, yes? Negative 12 divided by 3 is negative 4, yes? Negative 4 plus 1 is
3.
negative 3. So when my input was 6, what was my output? Negative 3. Now let's put it on the graph. Where do I find this point? 6, negative 3.
6 is the main x-axis on the right side.
So I go out 1, 2, 3, 4, 5, 6. Then what?
And then negative 3 down, so it's going to
Down. 1, 2, 3. Does everybody get it? Yes? Okay. I'm going to use a different color to do the next one. What is my next input? Negative 3. So what goes in the equation? Negative 3 plus 1. 2 negatives make a positive, yes? And what happens to these 3's? They cancel. So this negative 2 becomes positive 2, yes? Plus 1. What is 2 plus 1? 3. So when my input is negative 3, what is my output? Positive 3. And then I put that on the graph. Where does it go? 3 to the right? Left, 1, 2, 3, and then 3 up. Any problemos? No. Now I'm going to do a third color. What's my third input? 0. Negative 2/3 times 0 plus 1. What's that? 1. So I need a dot at 0 and 1. Where's 0 on the x-axis? I don't move, but I got to move to 1 on the y-axis, which is up 1. What do I do with those 3 dots now?
connect them.
Connect the dots. La 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 la. I got pre-made arrows.
Is that linear?
Yes, because it makes a nice straight line. How do you know it's linear? Check. I went over 3, down 2. Over 1, 2, 3, down 1, 2. Oh! Over 1, 2, 3, down 1, 2. Oh! Over 1, 2, 3, down 2. Oh! And I made the little steps that our man can run up if he needs to.
No one important.
Because they're big steps, he has to jump. Is everybody good? All right. Now, look at number 4 and tell me what's different. I'm going to rewrite the function g of x equals negative 2/3 x plus 1, right? Now, look at what I've been given. What's different? I have the answer, which is the output, don't I? Do I have an x? No, I have no x. X is still unknown.
But you could go on
But
the ground.
g of x is what?
Bless you. 1, 2, 3, 4.
G of x is 7, isn't it? Says so right here. So what can I write instead of g of x? 7. And what does that equal? Negative 2/3 x plus 1. Do I know how to solve that? What's the job of algebra?
Oh, you could take away the 1.
Minus 1 minus 1. So 6 equals negative 2/3 x. Now what do I got to get rid of?
I don't know how to get rid of the 2/3.
I got to get rid of this divided by 3, yes? So I'm going to multiply by 3 to get 18 equals negative 2x. Now what?
Now you take away
Take away,
2.
take away,
By 2.
divide by
2.
negative 2, and x equals what?
Negative 6. Oh no, negative 8. Positive 9. Negative 9. It's 9, sorry. It's 9.
Negative 9. Okay? So what then is the point on the graph here?
7 and negative
No.
negative 9, 7.
Negative 9, 7. Okay? Do algebra, Brad. I taught you grade 9. I know you know how to do algebra. Right? Oh. Well, he was just looking over at you and saying, do the math backwards.
Well, I know, but it's just like just saying the way you do it's super confusing. You know, so it's just not that.
Well, that's all I did. I did every piece of math backwards.
The way you wrote it out is just easier for you to do that. I always think
Is everybody good? Okay. Now let's look at this second one, and I'm warning you, it's gonna be tricky. What you do isn't tricky, but getting the numbers will be tricky. Do you understand? So I have a new function, m of x equals 4/3 x plus 2. I need the m of 7. What has x become?
7.
7. So this is 4/3. What is x now? 7 plus 2. Now you get to remember fractions. What is 7 really?
7. Wait, can you go 7 over 1?
Over 1. And then what do you do to multiply fractions?
You cross multiply.
You do not cross. You go straight across. 28 over 3. Right?
Yeah.
Plus 2. Now, what is 2 really?
Over 1.
2 over 1. Can I add those?
No.
No, why?
Because I don't have a common.
Don't have a common denominator. So it's 28 over 3 plus 6 over 3. Right? Because 6 divided by 3 is 2. To get me 34 over 3, which is a perfectly acceptable answer.
It's not as simple as form.
It is in simplest form, but you could also write it as 11 and 1/3. And you could also write it as 11.33. Repeating. Yes. The same way we always got 6 over 3. We needed a common denominator. So this 2 over 1 had to be over 3. How did I get from 1 to 3 times 3? What do I do to the bottom? I got to do to the top. Okay? Good? Okay, let's do the second one. M of 1 is 4/3 times what? 1 plus 2. Well, that's 4/3 plus 6/3, which is 4/3 plus 6/3? Anyone? 10/3, which is also 3 and 1/3 and 3.33 repeating. Is everyone okay? Now look at the last thing I am asking you to do. M of x is 5. So what goes here? 5 equals 4/3 x plus 2. Right? So now I got to get x by itself. Bryce is doing a lot of this in his head. He's just moving 2 over here and subtracting. I am writing every step because many of you stink at algebra. That's not just the way it is. Son of a bitch. So, rewrite this out. If you write every step, you can't do it wrong. I need to get rid of this 2 because I need x by itself. I see adding 2. How do I get rid of adding 2? Subtract 2. And if I don't do it to this side, it's not going to be equal anymore. So I do that to both sides. 3 equals 4/3 x. Now I need to get rid of divided by 3. So what do? Multiply both sides by 3. So now I have 9 equals 4x. Now what do?
Divide 4x by
Divide by 4, so x equals 9/4. Is everyone okay? Now many of you will be saying, and I'll get to you in a second, Josh, many of you will be saying that, oh, Mr. Reyes, this is so hard. In your work, I'm not going to give you a lot of fractions. Because fractions are difficult. But if you can do it with fractions, then can you do it with numbers? Yeah. Okay. So Josh, where is your disconnect? You must tell me where you are confuzzled. Everybody else, unless you are confuzzled, I want you to try number 6, which is exactly like number 5. You follow the same work, you're just using different numbers. Okay? Go. Josh.
Okay, the blue one I lost you the top part.
M of 1, so you're aware that the x in here becomes 1.
Yes.
4/3 times 1, you're aware is 4/3.
Yes.
We already knew that 2 was 6/3. Because we did it right here.
Okay.
So 4/3 plus 6/3 is 6 plus 4 is 10/3.
Yeah.
And then that's 3 1/3 and 3 1/3.
Okay.
Okay?
Next part I'm ready.
Well, in the last one we knew the output. So we knew this, we didn't know x. So we had to put a 5 in here. Instead of m of 1, we knew this whole thing was 5. But we didn't know where we started from. So then we did backwards math to get back to where we started. To find the input. Okay, let me show you one that's just numbers, because I think the fractions are hurting you more than anything. F of x equals 3x plus 1. You cool? So now I want the f of 2. Where does that 2 go? That 2 goes everywhere you see an x. So f of 2 equals 3 times 2 plus 1. What's the answer?
6. 7.
7. You can do that, yes? Okay, now watch. Pretend this isn't here. Okay? I'm going to erase it. The f of x equals 7. Now the function I gave you, right? Now, the f of x is 7. Do I know what x is? So can that change? No. But do I know what this whole thing is, the f of x? It's 7. So can I replace this whole thing with a 7? So now 7 equals 3x plus 1, yes? But I need x, don't I? So I do minus 1 minus 1. 6 equals 3x. You remember this from grade 9. Then I divide by 3, and x equals 2. Which we already knew from 2 seconds ago. Cool?
Yeah, I understand.
Okay. Now, you guys should be getting close. You should have done at least h of 2 by now. So, let's do that. H of 2 is going to be negative 1/4 times 2 minus 4. Negative 1/4 times 2 is negative 1/2, yes? Negative 1/2 minus 4 is negative 4.5. Is everyone okay? Everyone? Okay. Now I want the h of negative 2. Negative 1/4 times negative 2 minus 4. Well, negative times negative is going to be positive. We already know 2 times 1/4 is 1/2, so it's positive 1/2 minus 4, yes? Which, if you can't do that in your head, you go to your calculator, 0.5 minus 4, negative 3.5. Right? Everybody okay? Everyone is Gouda? Okay. Now, what's this last one? H of x, I should change colors, equals negative 1/4 x minus 4. What do I know here? Do I know x? No. Do I know the whole h of x? So what can I replace? I can replace the whole h of x with what? Negative 4 equals negative 1/4 x minus 4. How do I get rid of this minus 4? Plus 4. Where else? Plus 4. What's negative 4 plus 4? 0 equals negative 1/4 x. What is the only thing x can be to multiply to get 0? 0. So 0 equals x. Or x equals 0. Now, what are the 3 points that I would put on a graph? Which is the x value here? 2 or negative 4.5? 2. So it's 2, negative 4.5. What is this point that would be on the graph? Negative 2, negative 3.5. What is this point that would be on the graph? 0, negative 4. See how everyone can do it? Okay. Now, can you all read an equation? Touch your nose if you feel you can read an equation. Excellent. Can you substitute a number into an equation? Pat your head if you can do that. Okay. Everybody is good? Can you get an answer by doing the math the equation asks you to do? Yes. Rub your tummy. Once you have an input and an output, can you put it on a graph? Pat your head and rub your tummy. Start with rubbing your tummy. Now start patting your head.
I can do both. That's why it's that hard.
So everybody can go from equation to numbers to graph, yes?
I'm patting my tummy.
Okay. Turn the page over. Oh my good God, I have a graph and no equation.
But no, you do, because
But nothing changes. Because what is this graph made of? X's and Y's, yes? And those X's and Y's are X's and f of X's, aren't they? Can I do this? Excellent. Here's what we're going to do. The curve is the f of x. The straight line is the g of x.
okay, now you're confusing.
Why?
Because the f of x is supposed to be the same thing as y, isn't it?
No. This curve is the graph it's the equation. Okay? Just like on this last page, we gave you equations, and then we put them on the graph.
Yeah.
Well, in this case, you don't have the equation, you only have the graph.
Okay.
Cool? Okay. So, f of negative 3. What used to be written there? X. So that means this negative 3 must be an input. And where do we find it?
So is it negative 2 then?
Wait, just wait. Where do we find the inputs on a graph? On the x or the y-axis?
Oh, the input?
Or the x-axis, correct? So where is negative 3? Left, right here, correct?
Yeah.
Now, what is the output that goes with negative 3?
2.
Negative 2. Does everybody get it? So the f of negative 3 equals negative 2. Is everyone cool?
Wait, so how is this to know which one's which?
I told you which one was which.
So then for 0
I told you this is f of x. So if you're dealing with anything that's f, you're only looking at this curve. Okay? This, well, that's g of x. So now, here we're going to use g, yeah? So what's my input in the second one, which I will do with a red dot? 0 is my input, and where do I find that? On the x-axis. So I go to 0, and now I've got to find where 0 hits the g function. Where is it, Josh?
The right side.
I start at 0.
Oh, no, you gotta go
there's
up.
a 1.
I go up to right there, correct?
Yeah.
So the g of 0 equals what?
2. I got
2. Everybody good? Okay. In blue, the f of negative 2. So where do I go? I go to negative 2 on the x-axis, yes? Negative 2, and I'm looking on the f function. Is that the curve or the straight one? The curve. So I got to find where that curve is at negative 2. And it's right there, isn't it? So what's the answer? Negative 3. Does everyone see how this is working?
Yes.
All right. Now, I'm going to trick you. Is this an input or an output? F of x. It's an output, isn't it? So where do I look for outputs?
on the y-axis.
On the y-axis. What number do I need to go to?
0. Oh, you need to look at
1. So I go up to 1,
it's on 0.
and am I looking on the curved line or the straight line?
Curved line.
Curved line. So it's right there, isn't it? So when the f of x is 1, what's my x?
0.
Equals 0. Does everyone see how it works? Now you can go numbers to graph and graph to numbers, right? You guys try to do E and F. Just decide if you're looking for an output or an input, go to the appropriate axis, and then find where that hits the line that you were supposed to be looking for. Yeah, now would be a good time because I believe you know what you're doing. So, is this an input or an output? So where do I look? The y or the x-axis? And I need y equals what? 3. So I go to 3 on the y-axis, 1, 2, 3. And am I looking at the g function or the f function? The g function. So I got to find where on that line it hits. And it's right there, isn't it? I knew the 3, I wanted the x. So what is it?
Negative 1.
X equals negative 1. Everyone cool?
I did that kind of different.
That's
I
okay.
got the same thing.
That's
Just, like,
fine.
put it down here.
Well, that's wrong. Because
It's not
down is...
1.
But that's wrong.
Okay. So I go up?
No, you go to the output of 3, Vanessa.
Yeah, I did.
Output is on the y-axis. You got to go up to 3.
Okay.
and then find the line.
Okay.
So it's over here. Cool?
Yeah.
Because you have to every time. I understand. And finally, G of 4. Is that input or output? Input. So where do I look? X equals 4. And am I looking at which line? The straight line or the curvy line? Straight line. So I go out to 4. Oops. And I find it is right here. So the F when G of 4 equals 2. Is everybody good? Now you guys are smart kids. I've left a whole bunch of blank space at the bottom of these notes, haven't I? Why is that? Extra thing. Okay? I am going to write something up here. You are going to talk to your neighbor and see if you can figure it out. Okay? I am not writing something that you can't do. Okay? So don't look at what I'm about to write and say, I don't get it. Because you know how to do what I'm about to write. Is everybody ready? G of x equals x plus 4. Everybody cool? I'll change colors because it makes it easier. F of x equals 2x minus 3. Everybody cool? I want the F, change colors. I want you guys to tell me the F of the G of negative 2. That's crazy talk! Go.
So just solve probably after.
La 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 la. Figure it out.
I'm not asking you.
Okay.
Okay.
I'm drinking tea.
What you do first is how you're gonna want to solve it is you're gonna want to add, and then after you do the other side, right? So yeah, so solve it. And so then you'll be having after this 3x. And then I don't think it's really like divide it. The f it equals 3x or 3f 3. So then I feel like you said can you put the 3 into
X plus 4, and the F of X is 2X minus 3. Boom, boom. Does anybody have an idea? Okay. You have about another minute because I want to discuss your cumulative exam tomorrow and I want to show you this answer. What do you see here? G of negative 2. What do you see here? G of x. What is that x here? So this becomes the G of negative 2, which is what? Negative 2 plus 4, which is what? 2. So the G of negative 2 equals 2, doesn't it? What's that say? G of negative 2. What is the G of negative 2? 2. So what is this? It's really the f of 2, isn't it? Isn't it? Okay. Well, the f of 2 is right here, isn't it? What did this x become? 2. So I write 2 times 2 minus 3, which is 1. Does everyone see how it works?
I got that right. Genius right here.
Does everyone see how it works? How many functions could I pile on top of each other? Many as I want. You just work from the inside out, right? Right? Okay. Listen to me and listen to me closely. I'm going to give you your cumulative exam tomorrow. I'm going to give you 36 multiple choice questions.
Is it written or
36 MC on radicals, exponents, polynomial expansion, and factoring. 36 multiple choice questions. I'm going to give you 80 minutes. When these are done, you're going to work on all the rest of your stuff from your outline. I will in a sec, Madison. All of this is due Monday. It's due Monday. Okay? You guys are going to get this on Friday. Okay? I'm actually a liar. On Monday, you're going to do the written on all of this.
So Monday we have a test involved.
Monday you have the written part of your cumulative.
Alright, so
So really, all of this work is not due until Tuesday.
So quick question. We have about a week before us. Tomorrow, so that's the test grade. Oh no, Wednesday. Well, never mind. I'm an idiot.
No, you're
This
not.
part's gone.
It's okay, you're a smart boy. Don't worry.
All right? Is everybody good? Multiple choice tomorrow, written Monday.